now we are into how to model the plant using differential equations. Okay. Differential equations is a fully mathematical model that is governed by some math theorem depending on the model, such as Kirchhoff's law, Ohm's law, Newton's theorem. Right? At least in this course, we covered at least four types of systems. The first one is mechanical translational systems, or we can call it mass spring damper systems. So from here, if we consider this is a plans of the system we need to control, then we need to produce a model. Okay, now we can use this differential equations. Okay, this is we derive this using a free body diagrams. Probably you learn this in static and dynamics class. You can obtain these equations where m is a mass, k is a springs, this is a viscosity damper, and then this is xt is displacements after we apply the force to the mass. Okay, so basically ft is the input, xt is the output, the result of the inputs that produce the motions of m, so xt. So we have a model this system from a physical systems, or we can call it schematic system based on the actual physical systems. Then we transform them into differential equation here, which is m. The value of m, it depends on the system, so we can compute it later, but as of now we just consider m, right? And then Fv is the value of this viscosity damper, K is the spring constants, F is the input, right? So this is the differential equation that represents this system. So for mechanical rotational systems, we can use this the same method, but we can the term for torque and the angle, rotation angle is alpha, J is inertia, C is the frictions, which is equivalent to D here. K is the springs of the shaft, the spring effect of the shaft. Then we can produce this. Yep. All right. For electronic circuits, we can simply model resistor, inductor, capacitor networks. So from here we could also do the same thing. Then we can produce this model into differential in terms of differential equation. So the last one is electromechanical DC motors. So we can also model this into differential equation. All right. You can refer to textbook page 79 to 81 for the detail. Okay, I think that's all for plant modeling using differential equation. Of course, we will cover this later, but as of now, we need to see what is why, because later on we need to do some other method of other representations that use different methods. At least we can compare the the model between the frequency domain and this the time domain. Thanks for your attention.